Good morning, everybody. How you guys doing today? Happy Thursday. It's almost done there. All right. Wanted to try and let the track play out. Sorry for the trouble on Tuesday. I think hopefully getting the recording worked out for you folks. So I wanted to make sure I got the recording done and uploaded in time for you guys to be able to watch it before noon, so you didn't have to take extra time if you weren't planning on it. There we go. Let that stop. Awesome. So we are wrapping up Chapter 8 today. Right, our second look at classes and objects, and then we'll also talk about Project 2. I want to give this one to you, so you've got 2 weeks to get that one done. Don't forget, Project 1 is due tonight by 6 p.m. You have the same project as the evening class, so I felt a little bad about it, but some of the evening class people are here. I don't know if some morning people are in the evening or not, but so I'm going to go over the solution tonight at 6 p.m. for Project 1. So I've got to have it in. You have to commit and push to github.com. Then you need to submit the link to Desire to Learn. Right? If you just commit to github.com, I'm not going to know you did it. Right? So you got to commit and push, and then give me the link on github.com in D2L so I can go find your code. Right? And I'll be able to take a look at those. So I think it's going well. I had several questions from people, but that's all good. Questions are good. We're figuring it out. A couple of people had asked me, see if I can find it here, about the enable and disable landing gear. And I think most people figured out it was probably easier to just do it in one method. And that's okay. If you want to just do one method for it, I'm cool with that. Oh, excuse me. Come on. All right. So the enable and disable landing gear, if you want to do that all in one method, that's perfectly fine. If you want to do it in two methods, that's cool too. But change altitude should just be one. Right? That will just be a positive or negative number. It's not like fly up or fly down sort of thing. And then unit tests to get 100% code coverage as well. Okay, so I think that's going well. We're just going to wrap up the rest of Chapter 8 today. Open up NetBeans, get that loading here in a second. Questions about Project 1 before we move on to Chapter 8? What you guys got? Hopefully you have your coffee. Oh, someone did post. Question about change altitude. Yeah, what about change altitude? So the idea with change altitude is you're either going to give it a positive number to go up or a negative number to go down. You don't want it to go above the max, and it can't go below 1,000 if the landing gear isn't enabled. No, so change altitude should accept an integer as an argument to the method. So nothing in plain class should have anything to do with user input. You should not see anything about scanner anywhere inside of plain. Right? Because you want your classes to be portable, you want them to be independent, and you want them to just have that public interface that people interact with. So all the public methods are what they use. That's its API. If you're going to take user input at the keyboard, you do that as part of wherever you have your main method, because you know that part of your program is console-based. Right? We want our plain class to be amazing and fantastic and portable, so maybe we use it in a console app, maybe we use it in a web application, although I hope your plane doesn't run a web app. Maybe we use it in some embedded system. You can have a main method if you want. This doesn't require it. All you need is the plain class and then the tests. So if you want to add like a project1.java file with a main method, go for it. Yeah, you can keep changing up till 6 p.m. tonight. If you want to do that with the third. Yep, still good. So there's our chapter 8. Here we go. You find that there. I think this. Oh, did I? Apparently not. Let me close that one. That was not the right one. Chapter. All right, we'll just go find it. Sorry, thought I had it. Let's go open it here. We want 2151 for the winter. Then I'll just do it in one. Now I'm really confused. Chapter 8. Huh. Yeah, okay, we just changed it in here. So like bank account for deposit just accepts a money to deposit. Right? There's no a posture check. Thanks, Snake. I'll grab my little backboard thing here. There's no anything to do with scanner inside this class because we want bank account to be independent of that. So there's no user input happening. And a stretch. Oh. Greater than or equal to versus greater than. You're talking about for the feet here when we change altitude. So they can get to 1,000. Right? Where like with enable landing gear, if they're at 1,000, you can enable it. If you're greater than 1,000, you can't enable. So you can get to 1,000, then you can enable your landing gear, and then you can keep going lower and lower and lower if you want. Right? Okay. That make a little bit of sense? A hat. All right. I remember to bring a regular hat this time. Thought instead of the nice sun hat. Hopefully this will work. Okay, so sometimes it's greater than, sometimes it's greater than or equal to. Depends on what we're working on. Biggie, were you posting a link? Then it just got blocked or something? Or hat? Okay. I don't actually know. Like it turns into stars. I don't know. I didn't get a chance to see it. All right. So that one seems to make sense. All right. I'm pulling up the rest of 8 here. I'm sure I'm not going to miss anything. Yeah, another unit test. So like we were testing bank account, where we were testing withdraw. So we said, okay, well, we expect to have $10 left. That's what we expect. So to do that, we need to put $20 in the bank account to start. And then we're going to withdraw 10. And we're going to check, did we get a true result back? Right? Because it should give me true if it worked. So I'm going to assert true that my yes withdrawal worked. There was nothing wrong with it. And then I'm going to check my balance and see, does the balance actually match the expected 10? So I put 20 in and take 10 out. I should get 10. And again, with doubles, you have to use this little delta. Right, so that's one test. Does that make sense for what we're doing with withdrawal there? So that gets part of that here, right? That's testing that it will subtract the balance and return a true. We don't have 100% code coverage yet because we haven't checked this if statement, this if condition. Oh, I should format that. Right? We don't know if we're going to get back a false if we try and withdraw less than 0 or withdraw more than our balance, which the balance shouldn't change at all. So we need another test there for that one. So we're going to test withdrawal over the balance. So if I'm going to expect to have 10, I'm going to put $10 in. Then if I try and withdraw 20, I should get back a false result, and my balance should still be 10. It shouldn't have done anything to my balance if I asked for more money than I had. So that's the same sort of thing. That's how you get 100% code coverage. Sorry, I'm going back and forth with chat. So we need to make sure that every line of code will eventually run in our unit test. So I'm also trying the negative here. So technically this is one line of code, but I don't feel good knowing that my negative check works unless I tested it. Because it's really easy to screw these things up and put the wrong sign in here or do the weird thing. So like you expected it to work, but unless you write a unit test for it, you've got no guarantee. I mean, even a unit test isn't a guarantee, but you shouldn't have a good feeling about it unless you tried it. And that's what we do with our unit tests. Okay? All right, so where did we leave off? We did. We're going to talk about Enums. Right, so we did this portfolio that had classes as part of it with the aggregation is our technical term for that, where a class has another class. It's not inheritance, where a class is another class. We're just saying, hey, this one class has a bunch of another class, or has one of another class, or whatever it happens to be. Right, we have all that. Okay? Oh dear. Slides messed up. I want to make sure I'm telling you all the right stuff here. Throw these on, make sure I'm on the right screen here. There we go. Nice. All right. And then did we look at the this operator? Right, we did that. Yes, we did a constructor that calls another constructor, right, with the this operator. So we use it as referencing our attributes, and we can also use it to reference myself as a constructor. Say, hey, call this other constructor. Remember, it has to be first. And we can still do other things if we wanted, but we'll put it in here. Okay, that was the copy constructor. So at that point, the copy constructor actually should probably change, right? We should probably, instead of doing this, right, what we probably want to do is we want to change this one around. So let's change this one around. And let's say, instead of that, we want to call this with other stonk dot symbol, other stonk dot price or value, right? You know, I'm sorry, I don't remember which day I talked about the project. Give me just a second. I'm sure I can find it. And other stonk dot quantity. There we go. So if we call, and then we need to return, right? Nope. Oh dear, that's not working. Cursive constructor, yeah, that's fine. We want this one. We want that one. Oh dear, messed it up. It doesn't like that. How we can call ourselves? Why does it think it's recursive? All right, I don't know. Maybe it's smarter than I am. I'll just put it back. Oh well. Thought I could save a line of code, and then we'll set my quantity owned to the other stonk dot quantity owned. There we go. Now we fixed it. Okay, just making sure we're getting the correct values, because we added that here. Let's see. So I think I put it in, when I do the video archive, I think I named it. Let me take a peek here. So I'll try and give you guys all the links to the YouTube archives. You can always find them on Twitch, or at least for like 45 days you can find them on Twitch if you want the Twitch chat. I never figured out how to get chat onto the stream. but I guess I didn't spend enough time doing it. So yeah, it looks like I assigned project 1 on 121. Talk about project 1. Yep. Oh, and that one's not cased the right way. Bothers my OCD-ness here when these don't match. Classes. Update. There we go. Now we have proper casing here. That's super important, right? Super important. Not really, but that's okay. Excuse me. All right, and then we also talked about the null operator, right? Where we had null. And that was in here, right? So if I return something that was null, right, with the getting a stonk out of our portfolio, make sure we're doing a null check. So depending on your school of thought, a method returning null is gross because you get these null reference exceptions and then you have to spend so much time checking it. But other times it makes sense. I think a better way would be to raise an exception or throw an exception here. But again, we haven't talked about that yet because our ordering is really weird, but that's okay. So we'll just return null and we'll make the user have to check for it. And it's just ugly to like make the user have to check, hey, did I give you back a null or did I give you a real thing or not? But I guess it's probably just as bad to have to check for an exception. But okay. All right, so that's good. We did this. All right, an enum type. That's right. So now we're going to do the enum type. Let's see. What should we do for enum? Okay. So let's go and an enum is really just a way of putting a nice name to some values. Right, so if we were to, let's add a new class here. And let's call this an appointment. We'll figure out a way to schedule an appointment. This is going to be not a practical example, because you wouldn't actually do something like this in real life, but that's okay. Dates and times are hard. All right, so what we want to do is we want to add an enum type. So enum or enumerable, or it's a way of saying, hey, this is going to have a name, and I'm going to use it inside my code. I can use it by name to compare things. So we might have, this could be like an enum, and we'll call this one day of week. And then we say which one, what do we have? And typically these are all in uppercase. So it's like, I like Monday first. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Ooh, a dad joke. You got it. I got a good one here. I found this one the other night. I was thinking of you guys. Let's see. Where'd it go? Yes. So when back when we were on campus, I have two monitors, and sometimes I have another laptop over on the side. So I've got the main laptop and I got a monitor up above it because the left and right was hurting my neck because I don't use an external keyboard. I just use the laptop keyboard. So like I like to try and keep everything centered off of that. But back when we were on campus all the time, and we would see people. I'm acquaintances with the tech support folks. It was actually my first job was doing desktop support work at the Orchard Ridge campus. So I'm quite fond of the campus there. I was a student worker there, kind of like an intern program. It was really cool. And then I moved out full-time to the Auburn Hills campus and worked there. So I know the campuses, or those two at least. I don't think I've ever been to Highland Lakes. And then I've taken classes now at Royal Oak and Southfield. So I've been to those campuses as well. But when I'd see the IT folks who would sit and chat for a while, every time, every so often we get together for coffee and catch up and see how things were going. And every time I'd finish my cup of coffee, I'd always love to tell them that I've successfully installed Java. It was funny the first time, but when I told it to him every time we'd get together for coffee, it wasn't as funny anymore. All right, so we've got our Enum day of the week, and we can use this inside of our appointments. So our appointment then, let's make we'll have a private string for time, and you can do dates and things, but they're awkward. Exactly, yeah. Throw out those coffee emotes. I love it. The artist did such a good job with that. I was so happy how those turned out. So pretty. So we can have a time in here, like, because it might be a range, and it might have a start time and an end time, and okay, let's try that. Let's try a start time. We'll try an end time. Dates and times are really hard in code. I promise you, they're really hard. That's just what it is. So, all right, and then let's create a private day of week called, I don't know, the day. So the day of week now is one of these enums, and we're going to just call it the day. So we create our appointment. We're going to take a day of week. We're going to take a string for start time, string for start time, and we're going to take a string for end time. It'd help if you could spell these right. Day of week for day, and we just set them all, right? We'll take my this.day is the day, this.start time is the start time, this.end time is the end time. Okay, give that a little format. Then again, I don't want to have to do more work than I need to, so I'm going to right click and insert code and insert a bunch of getters. Yeah, I want all of them. Boom, now I've got my getters. And not a very interesting class, but sure, we can store a start time, we can store an end time, and we can store the day. Now, the reason why having an enum here was nice, right, is I don't need to handle this as a string and then have to do a bunch of string comparisons. Right? I can just say, hey, does the day of week equal the day of week? So if I were to go now make, let's do another class, we'll call this the calendar. No, maybe we should call it schedule. I don't like that. Let's rename this. So refactor, rename. We'll call this the schedule. Okay. It's going to have a bunch of appointments. So we'll have a array list of type appointment. We'll call that our appointments. It says, I don't know what an array list is. Sure, that's fine. I like array lists rather than arrays. They're just easier, right? Because we don't have to have a fixed size. And then we'll make a schedule. And its job, right, is to initialize this, appointments. So we need to make sure we create it equals a new array list of type appointments. Array list of appointments. Okay, so we have the array list, and then we should add the methods, right? Like void add appointment. We'll make this a Boolean, right? Boolean add appointment. Given an appointment. Right, so if you give me an appointment, I'll go add it to my list. So I'll take my appointments and I want to add the appointment. Awesome. Now we probably want to check something in here, right? To make sure that we're not overlapping. And again, this is why times are hard. Here, let's do this. Let's change this. So instead of start time and end time, let's do this. Enum, the time of day. Let's do that. We'll have morning. We'll have afternoon. And we'll have evening. There we go. I like that. I like that much better. So that's what, day of week? I don't know. Day and time of day? Day and time? I don't know. Sure, time. So we'll have a private time of day for time. We'll set my this dot time to the time. Okay, I like that better. Let's insert that getter. Insert my getter for time. Okay, give it a little format. There, now I'm happier. So we're going to check. Right, we can say for, and we want appointment. We can't call it appointment though. That's all right. For appointment, current appointment in my appointments list. Let's go do something. Let's check. We want to say if that appointment, the current appointment, dot day, and get day, equals the appointment dot get day, right? And the current appointment dot get time is equal to my appointment dot get time. So it makes these comparisons way easier when I do these. I'm going to say, hey, did the day equal the day? Did the time equal the time? And I don't have to worry about strings. I don't have to worry about maybe it was uppercase, maybe it was lowercase, that sort of thing. You know, now I'm feeling bad here. Day and time. Oh, should probably also have like, what's it for, right? So a private string, I don't know, type or message or something. I don't know. Details. How about that? String for details. Details, and then we'll add that get for get details. There we go. So if the day and time are the same, we don't want to add another appointment. But we don't want to check, like, are they equal to each other? Because you probably want to check, hey, if the details match and the day of the week and the time match, that would be equals. Right, using that equals operator. So I don't want to check if they're equal. I just want to say, hey, if they're in the same day and time, that's no good. Let's return false. Can't add that. If we do all of that and we haven't returned a false, I don't have the same day and same time, let's return true after we add it, right? Let's not forget appointments. Add our appointment. Oops, add the appointment. Okay, so if we found one on the same day and same time, don't add it, just return false right away. Format. There we go. If we didn't return false, then okay, it must be there. I can add the appointment. Call it true. We'll add it to my appointment book, right to my schedule. That make sense for that? How's this one feel? And kind of using that aggregation, like this one has a list of the others, but now we also want to be using this Enum type for comparisons. Okay, and then wherever I'm going to use that, now I can go reference those Enums in here. So we'll come back to chapter 8 and we'll ask them, hey, like what day, welcome to your appointment scheduler. Enter a day of week. And then we'll have a day of week. Actually, we don't have the string for day of week here. So we'll have a string for the day of week input or something. Keyboard.nextLine. Then I can go check. I want to say, okay, so if the day of week input dot equals ignore case, if they entered Monday, that sort of thing, ignoring case, then I'm going to have the enum, right? I'll have my appointment. Oops. Is this day of week? No. Appointment dot day of week dot Monday. Right, so we can make a new appointment, right? So new appointment, or yeah. So maybe we'll just have our day of week here then, right? Day of week equals Maybe we can assign a day. You can return a Boolean in your enable and disable landing gear methods, but you also need to make sure you're changing the value of that attribute. Your landing gear enabled attribute needs to change as well, right? It's not just returning the true or false. So make sure you change the value. And then if you want to do the return true because it worked or return false, it didn't work, great. I think it's a good habit. Oh man, mug's empty already. So it gets a little bit annoying because we still have to get some user input and turn it into days, but once we figure out what day it is, we can use the enum type and pass that around. And the other benefit of enums, and I think you'll get more into this into the data structures class, is that they are way faster because they're actually, I believe, integer values behind the scenes. I think so. Enum type. I think it's just an integer value. Yeah, I think it's essentially... I think they're pretty much integers. There's something a little bit particular about how they work, but so it's a lot easier than passing a bunch of strings around, which is really nice. And you can get that's right, you can get the value. So like day dot. There's a bunch of things we can do. Come on, day dot. There we go. A couple methods here. This ordinal, yeah, it gives you the integer value of it. So it's really its position. So what happens when you declare a bunch of enums is the first one is essentially 0. So it's 0, 1, 2, 3, 4, 5, 6, on and on and on, as many as you want to create. Right, so these are really easy to pass around. They store very efficiently in memory rather than having to store a string everywhere. So it's a good representation. And Mr. Gaddis has some other examples too, which is cool. Excuse me. Okay. Oh, we don't have a way to get our appointments back out, do we? Okay. So we should probably figure out a way to get our appointments back out. Well, we could give them the array list of type appointment. Get appointments. Appointments. So the problem is, what's going to happen if we return our array list? Hydration, oh thank you. Happens to be another mug of coffee here. Look at that, I am prepared. So if I just return my appointments, what happens here? Ooh, tea. Tea is good. I do like tea. So we just give them back our array list of appointments. Is that going to be a good thing or a bad thing, do you guys think? My toes are cold. I gotta go find my slippers. Remember I left those. A good thing? No, that's going to be a bad thing. That's a bad thing. Because what happens is they now have the reference to my array list. Right, so if I were to say, hey, I need my, let's make a schedule here, right? So let's make that schedule, my schedule equals new schedule, right? And then instead of having to say my schedule dot add appointment and give it an appointment, right? They can say my schedule dot get appointments. This here is an array list of type here. Let's do. How do we do that one here? So I think we can use var. Yeah. Appointment list. Yeah, there we go. So var, did you learn about this one in 1500? I think I mentioned it to my class. I don't remember if we actually did anything with it. And I told them, I discouraged people from using it because it's not lazy at all. And I do like it, and it definitely has good uses. But like when you're learning how to program, it can trip you up. So when you're learning how to program, it's really nice to say, hey, I know specifically what type this is. Like, hey, I know this is a schedule type, or I know this is a string type, or I know this is a stock type. What var is, var says, oh, your type is whatever's over here on this side. Right? And it's even going to suggest surround with comments. Why? So if get appointments gives me back, oh, where's it go? The array list, var will be the array list of type appointment. Anyway, the bad thing about that, though, now is I can go to my appointment list, and I can directly add or remove or interact with things. So I can add conflicting appointments. Right? I don't have to use the schedule class interface here to go through and add, which gives me that protection to make sure I don't add a duplicate appointment. So I've given them access to my private value here. Right? Array list of appointments should be private so that the only way they can change it is through my public methods that I have control over. If I just give them back my array list, I can do whatever they want with it. That's no good. So you got to be really careful with that. So let's not do that. Let's make sure they use my public methods. So what we could do then is if we want to get a copy of it, I think we've got this option. I think clone will work. Clone. I think that works. No? Nope, it doesn't have a clone. Hang on. Thought that would work. Let's see. Java Arraylist copy. Let's search it. There's probably something online here. How to clone a Java Arraylist from Stackoverflow. Create a new array list given the old list. Do you think that'll work? Oh, that's only a shallow copy. So a shallow copy means that they're both pointing at the same values internally. What we really want is a copy of every object inside of it here. Collections.copy. There we go. Let's try that. Destination and source. So this shallow and deep copy, we're not going to get too into it here. Or that's more of the data structures sort of thing. But what happens is, because all of these are just a bunch of appointments, appointment is a reference, right? So let's draw this out here. This is worth talking about for sure. And how cool is whiteboard? I love this tool. Clear. Clear. There we go. Okay. Let's do this in blue. I like blue. All right. So if I have this array list, and its type is appointment, I'm just going to do APP. Forgive me. My handwriting's terrible. Oh, look, my knuckles are right in front of the camera. That's funny. So inside of that array list, right, it's essentially an array with a bunch of spots for appointments. But appointment is a reference type. So what I store is the memory address, like 327B. And then the next appointment is maybe at 795A. The next appointment is maybe at, I don't know, A214. I don't really know. I mean, wherever these things are stored in memory is another appointment with its own set of values. So what's actually being stored in my array list are references. So if I make what's called a shallow copy, I'll make a brand new array list. So this array list here, say, is in its own location in memory, say x12bf, right? And then because it's an array, this is the size of one memory address. This is the size of one memory address. This is the size of one memory address. So its size, right? So it will go in memory for 3 memory addresses or whatever. That's contiguous blocks of memory. So you can get stuff by index. So you say, okay, give me the first thing. Give me the second thing. Give me the third thing, right? And we use it by index, and we'll just jump. So I know if I want the 0th thing, right? It's 0 times the size of a memory address. If I want the third index, it's 3 times the size of a memory address. I start here, I add that size, and I can read this location of memory right away. And so you get that instant access. I don't know if we talked about any of this before. I think we might have briefly when you talked about arrays, how there's contiguous memory. Array lists are similar here, but they can be a little bit smarter, where we can resize them. And they do some cool stuff. Learn about that in data structures behind the scenes, how they work. But anyway, so a shallow copy would give me a new array list of type appointment, pp. And we're going to say, oh, sure, that is now in a new spot. So this might be 642b in memory. But the values that it stores would be the exact same values. That's a shallow copy. So now I have 2 different array lists, but their values are both referencing the same object. Right? Just back like when we did talked about, hey, if you take one object and equal another object, right, we had to do the copy operator because we didn't want the copies of them to be aliases where you have 2 variables pointed at the same memory address. You get the same thing here. So what a deep copy does is it will copy the other things inside of it. So it'll make copies of appointment inside of that. That's what we really want. So we can try that. So let's make a new array list of type appointment. We'll call it copy. Here's a new array list type appointment. Oh, come on, I want that one. Type it for me. Come on. Array list type appointment. Nope, appointment. No, that's my daughter outside the door. All right, and then we're going to do collections.copy. Oh, no wonder it wasn't typing ahead. I didn't spell appointment right. Collections.copy. And we want to copy. Now, which one was it here? Which one was source and destination? We got to look this up here. Destination and source. So destination first. So copy to the copy from our appointments. And then we're going to return the copy. See if that works. Oh, no, that's okay. I used to have my office in the basement, and then we did some bedroom changes and moved things around, and the playroom got turned into my office upstairs, which is so much nicer because it's not like cold, dark basement. I like it up here, and it's usually not too bad. The kids usually play on the first floor, but every so often you'll hear them. No, I do have cats too. The cats will come out and bother me. So I've got 2 currently. Sorry, just a second. My sugar's too high right now. That's unfortunate. All right, so a copy. So we should see how well this works. Use diamond operator instead. Neat. You're allergic? Oh, so my brother was allergic. My older brother. So we never had cats when I was a kid. But my grandmother had cats, and I would go visit her a lot, and we'd spend time with her and do cool stuff. Yes, 6 p.m. Thanks, sweetie. Project 1 is due. Yeah, 6 p.m. But I always liked cats, and I liked her cats. So I always wanted cats. So once I moved out, I got my own place, got married, we got cats. It was awesome. So I still have 2 of our 5. The one is they're getting a little old though, that's unfortunate, but they're doing all right. I think I was sharing pictures. Someone else in class has cats, so we were sharing cat pictures in the Discord because that's the kind of content you guys need. Sure. All right, so let's see how well this works. So let's make a copy of appointments. So I'm not actually sure this will work. Well, let's give it a try. So let's add an appointment. So we'll just forget this whole asking them what day and time it is here. We'll just add some appointments. So we'll make an appointment. We'll call this CIS 2151 equals a new appointment. I can't spell appointment. It's new appointment. All right, and we have to give it the appointment dot, oh my goodness, appointment dot day of week dot Thursday. Oh goodness, should not be so hard. Time, morning, or message. CIS 2151. Okay, we got an appointment. Why is that tabbed funny? Now let's add that to the schedule. My schedule dot add CIS 2151. Awesome. Added. Okay, let's make a copy. So this is a array list. Oh, let's just do the bar. Appointments is my schedule. Get appointments. And let's see if they equal each other. Hopefully it's a copy. We're going to say print appointments index of at index contains nope. Get. There we go. Get 0. Does that equal CIS 2151? Okay. Let's see if it does. So we'll put a breakpoint in here. We're going to run this in debug mode and find out how well our copy works. Because what we want to have happen is we want a new appointment to be created in memory when we do that copy. We don't want two different appointments, two references to the same thing. That would make us sad. And I'm going to have to make some more coffee. Okay. Radius. Oops. Sure. All right, now we're here. So let's call get appointments. So let's step in and see what we get. Let's step into our code. We're here at appointments. So let's check our variables. Right, so this is this instance of schedule. This has the array list of appointments. Array list of appointments has one appointment. Thursday morning, CIS 2151. Okay, so we're going to make a copy, hopefully. Step. Copy it over. Uh-oh. Did it crash? Oh dear. Index out of bounds exception. Source does not fit in destination. Huh. Doesn't fit. Okay. Let's see. Can we make that the size of? No, we can do that. We can do that. Appointments dot size. Try making it the size. You can pre-size an array list, so we'll see if that works for us. Okay, step in. All right, now we made our copy. Let's see. We have this array list, appointments. Let's see. Step over. Crashed it again. Bummer. Source does not fit in destination. Wonder why it's doing that. See if we can just give it the appointment. See if we can start with the copy. We're getting there. We're getting there, folks. Step in, step over, step over. Okay, so that worked now. So if it was properly sized, that seems to have worked. Oops. So here we have appointments. We have another appointment. Let's continue some more. All right, so now we have our appointments list. Check that. And we have CIS 2151. No, it looks like it did not actually copy it. Bummer. They are both number 542 in memory. So this should probably tell us that they equal. Check our output. Yes, they do equal. Bummer. Okay, so it didn't copy. All right, you gotta do it the hard way. That's okay. We can do it the hard way. Let's make a copy constructor. Public appointment. Given another appointment. Other. Okay, this.day equals the other.day. This.time equals the other.time. And this.details, the other.details. Okay, so forget all that. Collections copy didn't work for us. It's all right. Equals a new appointment, and then we're going to say for appointment, appointment, and appointments. Let's take my copy. We're going to add an appointment given the appointment. Let's call the copy constructor for every one of these suckers and add it. Appointment. Yeah, it takes a while, don't worry. This is my appointment. Method, appointment, given an appointment. Can I have that? Oh, that's right. It's a new appointment. I did that last time too, right? Say, hey, I want a new appointment. We'll copy it, and then we'll return the copy. Now when we run this sucker, because we did our own copy process, this will be a lot better. Let's just give it a run. To scroll through code, oh, I've been doing this for years and years and years. So, there, now we get a false. You know, lots of practice, lots of writing code. When you do something professionally and you do it like 40 hours a week, that helps a lot too. So, no, don't feel bad. It's going to take a while, right? This is only like your second programming class, right? You did 1500 and you're doing this one. I mean, like just navigating around or reading stuff, or what? Like what? Anything in particular? Just shout at me if I'm like jumping through things that it doesn't make sense. Like I definitely want to spend the time to make it make sense for you folks. Oh, what variable to change? So this is like, I know that copy didn't work right because it had the same reference in memory. So when we went in debug mode, it doesn't give you the memory address, it gives you like a number, which is kind of a little funny, but that's okay. Let's give a radius, no. Okay, so right here in my variables, all these things have numbers over here in the value section. Remember the reference type. So what the value is, this is essentially its memory address. It's just numbering them for us because it's like this was the next variable you made, the next variable you made, yada, 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 on and on and on. So then when I step, now I'll get my appointments list and I'll have CIS 2151. Oops, sorry. I don't know that number. So I'll see this one is 526. And then inside of appointments, oh, you guys can't, oh, you can see that. Good. You'll see it's got 568. So it's a new thing in memory at this point here. So I know that the memory addresses don't match. Also, typically you want to write a little bit of code and run it. Write a little bit of code and run it. Write a little bit of code and run it. So that you know what you've just changed. So you can be focused on, okay, this is the part I'm working on, this little piece here. That's one of the reasons I really like test-driven development. Right? If we know what we're supposed to do, we write all the tests for it, and then we just pick one method at a time and make it work. Next method, make it work. Next method, make it work. Next method, make it work. Make it work. Make it work. Make it work. On and on and on. And if it worked at the beginning but not the end, you know, sometimes you just got to run it in debug mode. And you just step through and step through and step through and see. It's similar to when you unit test. Like, I know what I expect the variables to do and look like. So I'm going to use the debugger, and I'm going to watch and see, hey, are they doing what I expect? So that was all. So the debug mode is definitely your friend, because you can do that same sort of process. Like, oh, I know my GameStop should look like this, right? 92.44. Let's take a peek today, right? Totally, this is worth our time. Let's see how GameStop's doing. Worth the time. But we want to have a realistic example. I have to change hats if you give me another hat whisper. Wisp the third. All right. Change hats. That's what I get for not getting all my nice hats out. I got more. There we go. Mindful, I can only wear one, I'm sorry. Look at that, GameStop is dropping. $70 a share now. It's going down. Completely worth the points. Glad you think so. So, yeah. The volume is something interesting to look at too, like compared to the last couple days. Where's today? Yeah, volume. That was Wednesday. That's some high volume. A lot of volume early Tuesday. You know, it's hard to tell sometimes if the hedge funds made their short money back. Pretty sure they shorted it at less than $70 a share. Right, that's just a guess. That's just speculation at this point, but I'm pretty sure all of their shorts were for less than $70 a share. So, you know, we'll see. And some people think they still have a lot of shorts out. It's just a gamble at this point. Just a gamble. All right, why don't we take a break? We've gotten through Enums, and what else do we have left? We're going to talk about garbage collection, which is awesome. Finalize. Nice. Okay, I like it. So we are almost done, and then we can talk about the next project. So we'll take a quick break, get some coffee, and we'll go from there. We put some more music on for you folks. Let's see what we get. I think I've got this one on shuffle. And we've done that one before. Here, this one looks like a good one. All right, I'm gonna take 10, come back in a little bit. Hey everybody, welcome back. All right, there we go. I think this one's just finishing. Perfect. All right, so we are almost done with our content here for Chapter 8. Just a couple other things to note here. Java is a managed environment, right? We say that it runs in the Java virtual machine. Sorry, I need to get this one. There we go, so I can see chat. I know how to work my computer. So what happens when we create variables and we stop using variables is it will clean up for us. It does this thing called garbage collection. That's part of the Java virtual machine. It's managed code. Okay? So the way that it does that is it looks for variables that are no longer referenced or things that are no longer pointed to in memory. So if we make this schedule thing and then we want to get rid of it, like we want Java to clean up after ourselves, we can do that. It'll clean up eventually when the program finishes, but if we want to force it to clean up, we can say my schedule equals null. So if you assign something to null, assigning null will allow for garbage collection to free the memory. You know, in our case, we're not actually using all that much memory, so it doesn't matter too much. I mean, we're not doing hundreds and hundreds and hundreds and hundreds of these, thousands of these. Right? They don't take up a lot of space in memory, but they do take up some. So if we're not using it, we can put it to null and it will get cleaned up earlier. That's nice. I don't expect you guys to do it. It gets more important in your data structures and things when you are trying to scale stuff out to the zillions. So again, everything matters a little bit more at scale, but for our purposes, that's fine. I'm not too worried about it. And then if you want, you can add a method called finalize in your class that will run when you do garbage collection. Again, that's probably more of a special case, and we're not going to worry too much about it, but it can make sure that that class is then freeing up anything that it needs to free up. Not too big of a deal for our purposes. So yeah, that's about it there for Chapter 8. This was our second look at classes. Hopefully that was fun. So we're going to take a look at the next project then. So let me fire this up here. All right, we need project 2. All right, so this one will be due, we're going to go to the 18th at 6 p.m. So you can get it in before I go over the solution for the evening class, and then again, I'll cover it the next Tuesday with you folks in the morning. That way it gets in. And then this one, I think the last one was worth 10 points. Did I get that right for project 1? I think so. So we're going to do a little bit more here. Right? The projects will typically scale as we go. Make a new item, projects. Okay, yeah, 10. Okay, so this will be worth about 15 points. I'll get that rubric in as we go. Okay, so we're going to try and use some of these techniques, right? Sorry, just spacing out there. My sugar's messed up. Oh. Did not get a chance to go get more coffee. I was chatting in chat here. I think people were having some trouble. If you have trouble with the unit tests, let me know. All right, so we are stonks. I can't even click in here. All right, that's fine. Let me save and close. Come on, I'll reopen it. Edit. Aha, before I forget, this is what I need to do. I can change the submission here to not make people give me a file. So I'm sorry, that's obnoxious. But that's like its default, is everything's a submission. So it's just text. You just give me text. Okay? All right. So project 2 is we're going to try and build a poker game. So we're going to create a basic 5-card poker game. Okay, so we need a deck of cards. So we're going to have a class for deck of cards that is pretty much just a list. Card, so we'll need some class for card. Card should have enums for suit and face, right? The suit, the hearts, spades, clubs, diamonds. That's a weird way to say them, sorry. Spades, hearts, clubs, diamonds. I think that's how people usually say them. And then the face value, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ace, or jack, queen, king, and ace. Right, so 13 faces, 4 suits, 52 cards total in a deck. Okay. So we'll just have a card is just really just the representation of the suit and the face. Your deck has a bunch of cards, and then we'll create a hand, a 5-card hand for the computer player, and create a 5-card hand for the user. We want to display the user's cards to them. So like tell them, hey, these are your cards, right? And then we're going to have a game. So the game allows the user to as we're just going to say each player bets initially because it's really boring with just 2 players. Right, so as each player bet $1 initially. On the player's turn, they can raise or fold. I guess, yeah, raise, call, or fold. Okay, you raise. You know what? Forget that. Because we don't have any of those odds right now. That's okay. So we'll just So we wanted to show them. That's not going to work right. I wanted them to figure out the odds. Yeah, that's fine. That's fine. They can raise, call, or fold. If they raise, add $1 from the player's pool of money, and the computer will pick a random number and fold or call 50% of the time. Yeah, I mean, just like 2 of spades, 3 of hearts, 4 of diamonds. It's not pretty, but that's okay. So if you raise, the computer just either calls you or folds half the time. Just pick a random number to do that. After the hand is called, pair the hands to see who wins the money in the pot. Add that to the computer or player balance. So every time it's up to the player, every hand. So both people kick in $1, and then the player can either just call right away, or they can raise, or fold, I guess, is pretty silly. So just raise or call. Because you're not going to fold, because that just means you lose. So you can raise or call. If you raise, it takes another $1, and then the computer, half the time they'll call, half the time they'll just give up. Other than that, we're just going to see who wins. We have to compare the hands. So to compare hands, we want poker hands. Here's a, here we go, list of poker hands. Okay, so the best hand, we don't have 5 of a kind. We're not playing with jokers. So the best hand is a straight flush, and then a 4 of a kind, then a full house, then a flush, then a straight, then a 3 of a kind, then a 2 pair, then a 1 pair, then just high card. You have to see what hand you have to see if yours wins against the other hand. So for hand comparison, see this link. Comparison, sure. Okay. The poker hand class should have a method that accepts another poker hand class and compares itself. Compares itself to the other. So with my instance of hand, I'm going to compare myself to another hand, like you did with Powerball. We talked about that last, I think earlier on, like in Chapter 6, the review. So Powerball, given another Powerball ticket, would compare itself and see how much money it won. This poker hand will take another poker hand and compare itself. And we can return either we win, we draw, or we lose. Should win, draw, lose result. It's probably easiest to just use like 1, 0, or -1 or something here for poker hand. No, there's no copy constructor for there. We want, I think card. Let's do card should have that copy constructor. Because like poker hand should just be 5 cards. Poker hand class has 5 cards and. Well, let's say has. Here we go. So we'll use the poker hand as a private attribute for its 5 cards, and its constructor should. How do we want to get its cards? I'll just say it accepts 5 cards. You can do it a couple different ways, but this will work. You just give it 5 cards, right, for its constructor. And then we're going to have this, compare to another hand, return win, lose, or draw. So card, yeah, there's only one so 4 suits, 13 faces, 2 cards in a deck. Okay, so that's the class deck of cards here. Just a list of cards. Okay, and then we should do the deck doesn't need to copy card. We should have the card class. Of a copy constructor. A new card. Copy of another. No, just a single list should be fine. Doesn't have to be 2-dimensional. Just put 52 items in it, and then you can take them off as you go. Right, so as you take a card off, you can just remove it. Or you can just pick the top 5. You don't even really have to remove them from the deck there. We're not doing anything super interesting with the cards. And it gets shuffled every time. So really what you probably want to do is pick a random card, right, when you deal cards. So pick a random from the deck. And then you probably want to remove it, right? So that way you don't have duplicates. You don't pick again. That makes sense? So like the deck will have to start with 52. As we take a card off, just pick a random index, right, between 0 and the size of it. Get an index, grab that card, remove it, and give it to the user. So like to pick a card, your deck class could probably have like a get random card method. Deck should have a get random card method. Right, picks a random card, removes it, so you don't pick it again. So we'll make 5 cards for the computer player, 5 cards for the user. Tell the user what they get a bet, raise or call. That make sense? And just keep on going. Just keep running the game until the player quits or someone runs out of money. Right, so maybe you only start with like $10 or something. Can you do like 10 hands or so? See how it goes? Yeah, so this one, the game will be inside the main portion, right, where you're prompting the user, but you interact with the classes using their public methods. Right, we'll have to create the hands, we'll have to create the deck, shuffle the deck, or just make a new deck every time, right, get random card. So each hand gets a new deck. And each hand, let's start with a new deck. Each hand as well. We'll start with a new deck each hand. Right, that way you get 52 cards again to pick your 5 from. They can pick their 5. And then we can either bet, or we can just call, and we'll compare. We get the win, loss, or draw. So if you draw, then you split. You split the pot. So a draw, and let's play rounds. So draw, each player gets half the money. So the card class is going to have separate enums, one for suit and one for face. Like what we did for appointment, it had an enum for day of week and an enum for time of day. You could have an enum for face and an enum for suit. Yeah, class, I mean, I am a big fan of classes because I think it makes the way that things interact very clear. Because you understand this class represents this thing. These are the things you can do with this class. Right? A hand is just a bunch of cards. Sure. What do you do with a hand? Well, you can compare one hand to another hand. That sort of thing. So there is a compare. We haven't gotten there yet, so don't worry about the comparable stuff. We'll get to that part later. But so when you compare one hand to another, if you win, you should return some value to tell you you're winning. Usually, like a positive number is fine. 0 for draw, or lose. Or you could even return an enum. That could work too, right? You could return, where is it here? Yeah, this win, lose, or draw result. This could just be an enum, if you wanted. And then we could check the enum in our main method and say, okay, if they won, they get the pot. If they tied, they get half the pot, and the computer gets half the pot. Or if they lost, the computer gets the pot. So like an enum might be fine there. If you just return a 1, 0, or -1, you know, that's essentially the same thing we're doing with enums. Let's do that. Let's make this an enum result. So we'll have an enum for win, lose, and draw that we can return. So the comparison here is actually kind of tricky, right? To find out what we have. Right? So using this rank here is actually pretty helpful too, because you can compare ranks, and then you can say whether or not my rank is better than your rank. Yes, yeah, the comparison is the hard part, for sure. So I would recommend you go by rank, so find the rank of your hand. So poker hand could have a method like get rank, and it could return, hey, am I a 4 of a kind, am I a full house, am I a flush, am I a straight, 3 of a kind, 2 pair, 1 pair, high card, whatever. On and on and on. Right? And then we can just compare ranks. So if my rank is better than your rank, I just immediately win. If we have the same rank, then we have to do tie breaks. Tie breaks are tricky. So with a straight flush, the highest card will win. So if we both have a straight flush, but my straight flush starts with a 9 and your straight flush starts with a king, your straight flush wins. If we both have a 4 of a kind, the higher 4 of a kind wins. Right? If we both have a full house, the higher 3 of a kind wins. If we both have a flush, the highest card wins, but if we both have the same highest card, you have to check the next card. If our second highest card is the same, we check the third highest card, and the second, on and on and on. So it's possible to have equivalent straight flushes, equivalent flushes, same with straights. You can't have the same 4 of a kind. You can't have the same full house, because there's not more than 4 cards in the deck. So there's no tying when it comes to a 4 of a kind. One will always win versus the other. Same with full house. But a straight flush, flush, and straight could tie. Right? Because you could have flushes in different suits. You could have straights with different cards. 3 of a kind, again, will always have a winner. 2 pair now gets tricky. You compare the first pair. If the first pair is the same, you compare the second pair. The second pair is the same, you compare the last card. 1 pair, highest pair, right? Or you check the pair, highest pair wins. If they're the same, you check the next 3 cards. And then just high card. So comparisons is going to be tricky. So we want, when we compare, where'd that go here? So when comparing poker hands, first determine rank. And rank. A private method. You know, that might even be public. Because like you could display your hand if you wanted. I promise it's not so bad. It's not so bad. What we just need to do is take it one step at a time, right? How do I find hand ranks? Great. Now, how do I do tie breaks? Great. How do I tie break this one? How do I tie break this one? How do I tie break this one? It's good. That uses a rank enum. Again, enums are fantastic. So what I'm going to recommend you do, right, you can actually compare enums, because remember they have that ordinal value. So this enum is less than this enum, is less than this enum, is less than this one, is less than this one, is less than this one, is less than this one. So your last enum is the greatest. So if you put these ranks in reverse order here, so if high card is the first enum, then 1 pair, then 2 pair, then 3 pair, 3 of a kind, straight flush, full house, 4 of a kind, straight flush. Straight flush will be just greatest. When I say, hey, my hand.get rank versus your hand.get rank, I can just greater than, less than, or equal to right away. Really quick. Yeah, it's a fancy number. Yep, just a fancy number. Okay. The ranks are different. The better rank wins. The hand ranks are the same. Need to determine the tiebreaker. Some ranks will can tie, others cannot. Sorry, yeah, I think I had a little bit of lag. My bitrate was dropping there. It was going so good, too. It was going so good. Sorry. Uh-oh. Oh, no. My bits. I'm losing it. I was doing so good here. Let's see. Maybe I can close. Start closing stuff, see if that helps. Oh, the voice is still there? It says I've got like no kilobits per second. That's crazy. Oop. I don't know what a replay buffer is, code, I'm sorry. Not sure what that means. It's a button on OBS. Is it in settings? Error decoding. Oh, yep. Oh, there we go. Now I think I'm back. How about now? Replay buffer. I don't know what that means. Sorry. I'll have to look and see. Okay, cool. Good enough? Ah, keep replay buffer active when stream stops? That's neat. I don't know what that means. All right. Oh, excuse me. So anyway, comparisons. Sorry about that. Maybe someone started streaming for school downstairs. Who knows? Or Comcast. We can always blame Comcast. I think you guys told me I was allowed to do that, right? All right. So again, determine hand rank first. That's your first problem. If you don't get the tie breaks, that's okay. It's not going to kill you. I'll show you the rubric. I got to work on that here in a minute. But like the tie breaking portion is only going to be a small part of the points. So like, let's focus on the pieces here. Oh, one player and one computer. So it's just heads up. We don't need, tracking multiple players would be more complicated, which would be a lot of fun, but again, probably a little bit beyond what we want to do for this project. Okay? Infinite play. Well, so you do have one 52 card deck. So I'm pretty sure you can at most have 10 players with 5 card heads up poker. And 5 card poker is boring anyway, but that's okay. My kids started learning it. They started playing with their grandparents when we were out in Philadelphia for a month. So they started learning how to play. Yeah, your Comcast just okay. I'm glad it wasn't just me. Well, no, I'm sorry that happened to you, but I'm still glad. You know what I mean, right? Right, Wisp the third. Okay, so questions about this. Again, you guys are welcome to discuss ideas about this, but don't be sharing code. Right, so if you want to like sketch out, hey, this is the sort of method I would do to figure out which hand I have, great. I'm fine with you guys working together on that part of thing, but don't share the code. Okay? Infinite deck messes things up because then you have 5 card hands and it's really screwy, and then like none of the odds make any sense anymore. So you want a single deck. Okay. Oh, I forgot my hat. I'm sorry. I took it off. My head was itchy. While I was on break. I owed you guys the hat. All right. So copy constructor for card to make new cards. Sure. Okay, we'll have the deck class. So again, we're trying to model classes here and use them. And it's possible to go overboard, but I think we're going to do pretty well. So we'll have a class for card, we'll have a class for deck, we'll have a class for poker hand. Right? Poker hand has 5 cards, deck has 52 cards in it. Right? And then they talk to each other. So a poker hand can compare itself to another poker hand, give you that win, lose, or draw Enum. So again, go for rank first. Figure out which rank you are. So you want a rank Enum. Will make life easy. A rank Enum. And then if my rank Enum is better than yours, so I can do it in reverse order. So I'll make high card first. Right, so we can have like a get hand rank method. It's going to tell me, hey, am I a straight flush? Am I a 4 of a kind? Am I a full house? Am I a flush? Am I a straight? Am I a 3 of a kind? 2 pair, 1 pair, high card. And make sure you go in that order too, because a straight flush is a flush and is a straight. And if you tell me my straight flush is a straight and I lose to another hand, I'm going to be upset with you. Right? Okay. Then we're also going to include unit tests to ensure 100% code coverage of the poker hand class. all the pair and rank stuff. Right? That's really what we care about. So yeah, the game part, just in a main, just in a loop here, just keeps on going until the players run out of money. They can either raise or they can call. Because folding's silly at this point. Like, we just say they both bet $1 to start. And it's not exactly how that works. You're depending on what flavor of poker you're playing, right? It might be a little bit different. We'll just say they both kick in $1. Computer kicks in $1, player kicks in $1. If your hand's not great, just call. If you think your hand is good, you might want to raise. And we're just going to have the computer randomly, either call or maybe it will just fold and give up. So maybe you can bully the computer because it'll just give up half the time and you'll make your money. It's not a smart computer. It's just, sure. We'll figure out how to make it smart later. Don't worry. Don't worry. Hey, Uncle Bill. Thanks for dropping by. Shout out to our friends at the Knowledge Fellowship. That's exclam TKF in chat. Go learn some stuff. Go get learned. We're just wrapping up class. We're talking about our next assignment here. I'm going to do a silly little 5-card poker simulator. Okay, so leave the tie-breaking for last, right? Just figure out how we can do ranks first, and then come back for tie breaks. It's definitely a better strategy for you. Because if you start getting into how do I do the tie breaks for specific ranks, then it's going to make your head hurt. And you can just tackle one at a time, right? Straight flush, we can tie break. 4 of a kind, there's no tie break. Full house, there's no tie break. I'm sorry, there's no tie. My apologies. There is a tie break. So the better 4 of a kind is the higher 4 of a kind card. Right, the full house, the better full house is the higher 3 of a kind. With a flush, it's highest card compared to highest card, next highest card compared to next highest card, on down. So this one could possibly tie, or maybe your 5th card is the winner, or is what determines whether or not you win or not. Maybe it's the first card. Maybe we've got to go in order. Right, to do that, you might want to do the same thing with card, where one card can compare itself to another card. And cards compare themselves by face. So you just check the face value. You're either same face, you're equal. Your face is higher, you're higher, or your face is lower, you're lower. Did I go quiet again? Uh-oh. I think that means it's time to be done. We'll talk more about it, too. I can answer more questions about it. Okay. So, and it's going to help when you add cards. Keep them sorted below. Make life easier. Right, for both hands, really. So if you figure out when you poker hand, when you add a card. Maybe we don't want a constructor for that then, do we? Maybe we do. Yeah, we don't want to accept the 5 cards, do we? Because we want to be able to sort them. That's okay. We can go through all 5 and sort them. So, sort them in the constructor. If you sort them there, it's going to make life a lot easier. Promise. Okay, I'll show you a trick for that next week. All right, I think we're about out of time. But we'll talk more about this next week. Don't worry. Let me save this here. I'll add the rubric in a little bit for you so we can talk about it. Next week, we're moving into files. So we'll spend a little time with files. And then we'll talk more about the project as well. Okay, any other questions before we go? Again, I've got limited office hours today. Today's my crazy day. Just before my evening class is about all I've got set aside. So hopefully things are done with Project 1 We'll talk more about text processing and wrapper classes next week, and then we'll move on into inheritance. Okay? And then we'll talk about, we'll have time to answer questions about the project. Okay? Thanks. You guys take care. I will see you around. Oh, let's see if there's anybody around we can raid for fun. Who's around? Maybe check on Discord, see what else is on. Psych. We can go learn some psychology. Right? That might be fun. Psychology's good stuff. Let's see if we can do that. Let's see. How do I... That's the button I want. Let's go say hi. Okay, cool. Raid is going to work. So again, totally optional. Just part of the fun. We'll do that, and I'll see you around.